Okay, today we're going to work on topic 2.3, which is changes of matter. So topic 2.2, we were working on how to identify and classify properties. You had the physical properties, which were subdivided into intensive versus extensive, and then you had chemical properties. Today we're going to talk about how we can change matter. So just like properties, we can subcategorize changes of matter as either being a physical change or a chemical change. When looking for a physical change, this is where you are changing the substance in a way that does not alter the identity or the composition of it. So if you start with something that is chemically H2O, you need to end with something that is still chemically H2O. If you have a sample of copper, it must still be copper at the end. If you have a salt water mixture, it must still have that chemical water and salt components still there. So we're not producing anything new. So, what are some things that you can do in order to cause a physical change? One kind of category can be a change in shape. So, I have a piece of aluminum foil in the corner there that is crumpled up. That's an example of that. A change in size. You've probably seen that logo before with this device here. This is a mortar and pestle that's used a lot in the science realm, especially in chemistry, to break things up into a smaller surface area to make things dissolve easier, things like that. And so that's change in size. You start with a tablet, grind it up so it's still chemically the same component. And then changes in state and phase. That's why I had you guys do that simulation the day before to work through understanding what it means to go through a phase change and working on identifying our different phase changes that exist. So when you're boiling water, for example, like with the tea kettle with the steam, it started out with liquid water and then you're ending up with water in a vapor or gaseous state. So it's still chemically the same, it's just in a different state or form. So phase changes are often identified as chemical changes, but you have to understand what it really means to be undergoing a phase change. And that's basically, if you take a look at what it means to be a solid, liquid, and gas between the PhET lab and the Gizmos lab, hopefully you started to make the connection that it's just a relationship to how much energy those particles have. And so heat, also known as thermal energy, can transfer from one material to another. And so that's what allows a phase change to happen. So if you have an ice cube sitting in your hand, what's allowing that to take place is you have more heat relative to the ice. So the heat from your hand flows into the ice cube, which is where you get the perception that it is cold. The next idea is that a phase change is reversible. So you could take that liquid water that's puddled into your hand and you could put it into something and put it back in the freezer and change it back to a solid. So again, at all points, it's still water. And so again, a phase change, no matter which one you're talking about, it's a physical change, not a chemical change. So I have this chart here that we're going to use to describe and identify what it means to be are all 6 phase changes that can take place. So you may want to pause your video at this time. Go ahead and see if you can find a red and blue colored pencil, pen, some kind of writing utensil. So if you need to find something red and blue, go ahead and take a moment to pause and find those items. So the first thing we're going to do in this chart is we need to draw our 3 states of matter. So we're going to put solid here, we're going to put liquid in the middle, and we're going to put gas all the way down here. The next thing that we're going to do is we are going to go ahead and draw a particle diagram for each of these. So if you remember, solid is nice and orderly with the particles very close together, and they're essentially vibrating in place. A liquid, they're close together, maybe not as orderly, which allows them to flow. And then a gas we know is widely spread out, mostly empty space. So again, as we look at this, what we know is as we go from left to right is we're increasing the amount of energy or kinetic energy, how much motion they have. Solids very little, liquids are intermediate, and gases have the most. So we're going to talk about this from 2 standpoints. What happens? How can we name these phase changes as heat or what we really mean is just energy is added. Heat is just a form of energy. So as we go through these, there are 6 phase changes, and I'm realizing now my arrows didn't show up because of the background. So let me go ahead and add some arrows real quick as we go this direction. And then I'm going to go ahead and add my 2 going this way. Okay, so if you think about it, and this is where I'm going to use my red writing utensil. So what is it called when a solid changes to a liquid? That is called melting. And the reason why I'm writing it in red is that's telling me that it takes heat. It means you have to add energy to those solid atoms in order to get them moving faster. That allows the phase change to take place. If you add more energy to that liquid water and it gets them moving fast enough that they start to space out and really spread out, they change to a gas. That's called vaporization. There's 2 types of vaporization. There's boiling or evaporation. Evaporation is kind of a not necessarily spontaneous is maybe not the word I want to use, but it happens on its own without input of energy. If you leave a glass of water sitting out, with time all that water dissipates where it's gone from the liquid to gas state. Boiling involves kind of a heat source, so you have, a burner, things like that involved on a stove. And lastly, this one is not probably recognized as much, but you can add enough energy to change a solid directly to a gas without a liquid intermediate. And this is called sublimation. You guys have seen sublimation before in kind of maybe 2 different places. If you've ever had the air fresheners that are the little cones that have that solid, and then with time they've just disappeared, that's sublimation. That's changing directly to a gas, which you then perceive as that fragrance in a room. The other place is dry ice, which is solid carbon dioxide. And then a lot of times at Halloween, you use it for decorations and stuff like that, and like haunted houses and that. And so that is changing directly to the gas state of carbon dioxide. That's another example of sublimation. I'm going to go ahead and change my writing utensil color to blue, meaning that these have to lose energy in order for the phase change to happen. So if we go in reverse, and if we want to slow those gas molecules down to change them to a liquid state, that means they have to lose energy. They have to give away heat. And that's called condensation. So a place that you oftentimes come up with condensation is on the outside of a cold pop can or pop bottle, in that you've slowed the molecules down enough, in that it's lost enough energy. And so that happens because your container is cold, and it allows the water in the atmosphere around it to slow down to go from that gas state to liquid. So again, as we go from right to left, these have to lose energy to the surroundings. And then if we go further over, if we want to change a liquid to a gas, we have a liquid to a solid, we have a very technical terminology, and that's solidification or freezing. So when you guys encounter these, the ones up here in red are what's going to feel cold to the touch. So imagine having an ice cube in your hand. It's a solid state, and as it melts and changes to a liquid, you perceive it as cold. And the reason why it's red here is that it's saying it's what's called endothermic. It has to take heat in to get those molecules moving faster. So these endothermic changes here in red are what you perceive as cold. Going in reverse, these changes here, the condensation and then solidification, you're going to perceive as being warm because they have to lose energy in order to slow those molecules down. And here I've skipped this last one. So a gas can also change directly to a solid. This is called deposition. And you have also seen deposition before, and that's when you get frost on your windshield in the wintertime. That's where water, again, in the atmosphere loses its energy quickly enough that it doesn't have a liquid intermediate. It goes directly to a solid state, which is then the frost on your windshield that you then get to scrape off. So these are the 6 phase changes, along with if energy had to be added or removed. So like I said, energy may have to enter the system. Okay, so if it has to go into the system, and I'm going to use red again here, that is called endothermic. So that prefix endo means within. So there are 3 phase changes that are endothermic. So again, that was melting, vaporization, and sublimation. And this is because, again, heat is added to the system. On the flip side, we then have what's called exothermic, which the prefix exo, you can probably make a pretty good conclusion here, is it has to exit the system. So the prefix exo means that heat is leaving. So we have to slow particles down. This is called condensation, solidification, and finally deposition. So again, in these scenarios, heat is removed. And this allows the molecules or atoms to move slower and slower to cause that phase change to take place. So again, all of these in this diagram are all physical changes that can take place to matter. At no point are you changing the composition, you're only changing the state. So on the other side of things, chemical changes are where we are going to go ahead and make something new. So places that you've seen chemical changes, so if you burn something, you're producing something new. Rusting is where iron is exposed to oxygen to make iron 3 oxide, or what we call rust. Tarnishing, so the Statue of Liberty is actually copper plated, and so when you think of copper, you don't think of green, but that's copper that is oxidized with oxygen in the air. And so how we perceive the Statue of Liberty as green is not its true color, but it's changed with time because of a chemical change. Decomposition, so decomposition can have multiple meanings in a chemistry aspect. You may have more of a biology, things breaking down and returning nutrients, which is definitely places. And then there's other ways that we can decompose or break down chemicals besides things rotting away. And then any kind of cooking includes a chemical change. So as you fry an egg, bake a cake, anything like that, you're changing the composition of the material. So how can you know that a chemical change is taking place? The first one is color change, which is not always the best indicator. So if you think about it, if you turn on the old style burners that have that coil and they start turning and glowing red, you're like, well, that's a change in color. You're not chemically changing anything. It's releasing light energy due to electrons. So we're not seeing a color change there because you're changing the composition. Whereas we enter fall, we're going to start to see the leaves expose different colors. And that's because of chlorophyll in the leaves are now decomposing, breaking down, and we can start to see the other chlorophylls and other pigments that are always in those leaves. So those orange and red colors are always there, but the other chlorophyll A and B mask those other colors. And so that's where we can start to see that because there's things breaking down within that leaf. So chemical changes, color change is not always the best because there's sometimes physical changes can be a color change as well. So what are some other good pieces that you can use to identify chemical change? If you notice an odor, so a lot of times in chemistry, certain reactions can produce an odor. The next one is what's called formation of a precipitate. So precipitate, we're not talking like precipitation like rain or snow. We're talking about a precipitate when you can see on the left-hand side, you have 2 colorless liquids that almost look like water. Those are 2 solutions. One is lead iodide, the other one contains potassium nitrate. When you put the 2 together, you start to see that yellow color form. That is the precipitate itself. It's a solid. If you would give it enough time, it allows that material to settle out. So for those of you that will return to the classroom when that opportunity presents itself, that's something that we will do back in the lab, is make precipitates for many different reasons. So that's something you see a lot and use a lot in chemistry. Bubbles being formed or gas. So a lot of times you see foaming. You may hear a sound with it as well. So this is zinc metal submerged in hydrochloric acid. So that's where fizzing is happening. Okay. So the next thing I want to talk about is with boiling. When you think about making a pot of water to make spaghetti, you see bubbles forming. Again, that's a phase change taking place there. That is not a formation of a new substance. And then the last one is light and or heat is released. So this is thermite, which is a pretty dangerous material, but it releases a lot of heat along with light. So when it comes to chemical changes, there are instances where multiple things can be your evidence. So again, you have to think about what can you see to determine if it's a chemical change. So I have some examples here that we'll take a look at, and we have to classify them as a physical or chemical change. For physical, I'm going to use PC. For chemical change, I'll use CC. So salt dissolves in water. Anytime you dissolve something, it still is salt and it's water. What you can do is you could let all of that water evaporate over time, and you're going to see salt crystals that remain behind. So anytime you dissolve something, that is a physical change. You did not produce anything new. It's a change in state, essentially. Hydrochloric acid reacts with magnesium to produce hydrogen gas, so it's talking about something new being formed. I would say that's a chemical change. A piece of copper is cut in half, so you've changed it, but it's still copper in each half. You didn't produce anything new, so that's physical. Water boils and produces steam, so we start out with liquid water that changes to a vapor or a gas. So it's still chemically water, so that's physical change as well. Milk souring, hopefully you've never had that experience, but if you've ever tasted sour milk, you can probably tell us that it's terrible and it's not an experience that you would want to repeat. And that's because you're producing an acid when that breaks down, so that is a chemical change. And then an egg is fried in an iron skillet. Again, anytime something is cooked, it is a chemical change. So you produce something new. So then here we have, and just ignore these, it must have goofed up when I was setting this up the other day. So when we take a look at these, here's particle diagrams that we can interpret as a physical or chemical change. If you look at your starting material, that's what's on the left side of the arrow. The right-hand side is the after, what was formed. So if you take a look, we have two different things going on here. We have one material, two materials. So we have two elements, and if you remember, these are called diatomic elements because they're bonded together. You look on the product side, or what is ultimately being formed here, these are not the exact same. So for it to be a physical change, we should see these two same things, maybe just arranged a little bit different on the product side. But we see a whole new material, and that whole new material is made out of two of the small black spheres to one of the larger white spheres. So this is going to be a chemical change, and that's because a new compound is formed. Okay, if we take a look here, this is one piece of the material, that's a compound, and every other piece looks the same to it. When we go to the product side, we see the exact same thing. The arrangement has just changed. So it's still chemically the same, so this is a physical change, and that's just because of a change in arrangement. Based on the arrangement, you could probably assume that this is melting, that it was probably a solid changing to a liquid maybe. So when we take a look here, we have this piece in our starting pieces, and we have this other material. When we take a look at the product side, or the ending material over here, this is all that we have, and it's a completely different ratio. So this is also going to be considered a chemical change. And again, we have new compound formed. And last but not least, we have essentially just an element. And if you take a look at the product side, it's still the same. So this is going to be a physical change, and it was just a change in the arrangement. So if you have questions about what we covered today with physical and chemical changes, please send me an email or a Google Hangout. Otherwise, good luck on your homework.